All right, hi guys. Today we're going to do our first part of our review for our CBA. Please do write all the examples in your notes. You do not have to write everything that you see on your screen. I do want you to write anything that says examples or that I point out you should write. Just label this section CBA 1 review. You can always write more than I require, but please at least write the examples. All right, let's talk about like terms. So the definition of like terms, it's the same variable with the same exponent. Think of people with different last names. So someone with the last name of Robinson is different from someone with the last name of Robertson, even though they sound alike. So it's the same with x and x squared. They look a lot alike, but they're really different. They're different families. So for example, x and negative 5x, that would be like having John Robertson and Mary Robertson. They have the same last name, they're family. But then y and 23y, that's a different family. 8b squared and negative 0.5b squared. Those are like terms because of the same variable, b, and the exponent's the same, that 2. Same thing with numbers, 13 and 23,408. If it's just a number, no variable, then they're like terms. So for example, here we got two like terms. We got these two right here, 2x squared, negative 8x squared. Again, that's like having Robertson. They're both Robertson, but this is Robinson. Think of your x's as your Robinsons. He's not from the same family, so negative 3x is not a like term. Same thing with this plus 3. That's another family. So make sure it has the same variable with the same exponent. Then you can combine them. All right, distributing, that's been causing some problems for us. So anything that's outside of the parentheses and touching it is what's going to be distributed. And to distribute, that means to multiply by everything that's inside the parentheses. So here's some examples. Do write down these examples in your journal. Here's the first one. We've got 5 times the quantity x minus 2. I'm going to use a little pen to help you out. Let's use red. So when I say distribute, I mean take this 5, multiply it by x, and then take the 5 and multiply it by negative 2. And when you get that, you should realize that's 5x minus 10. Let's look at another example. We have 3 plus 2 times the quantity negative y plus 4. So again, it might be helpful to look at my pen. Notice only the 2 is next to the parentheses. The 3 is not. So you're going to multiply 2 by negative y, and then you're going to multiply 2 by 4. And when you do that, you should get 3 minus 2y plus 8. Okay, next example. A minus 3 times the quantity 2 minus b. So notice, we're going to multiply everything on the inside by negative 3. That negative is really important. People tend to forget it. So you're going to do negative 3 times 2 and negative 3 times negative b. So when we do that, your a drops down, and then you get negative 3 times 2 is negative 6, and negative 3 times negative b is positive 3b. All right, one more example. 3 minus the quantity 4 minus 2x. So really, here's what you need to do. Whenever you see a minus right next to the parentheses, think this is a minus 1. I know, not the prettiest minus 1. And then distribute it to the 4 and distribute it to the negative 2x. And when you do that, you should drop down your 3, get minus 4 and plus 2x. And then you could simplify that. So simplifying and solving, everyone gets this mixed up. So when you simplify, usually you do not have equals or less than or greater than or not equal to or less than or equal to or greater than or equal to. It doesn't have any of those, usually. So your first step is under grouping, which is usually parentheses. Second step, combine like terms, which if you go back in the video, you can see what like terms are. And we're going to jump right into examples. So write this example down. And y'all know how I feel about colors. So we said we need to undo grouping. So remember, like we just said, that negative is really -1. We need to multiply everything inside by -1. So when you get that, when you do that, you're going to end up with this. Oh, if it'll let me do it. Oh, come on, computer. There we go. -2 minus x, and then we drop down -3x plus 10. All right, then we're going to find our like terms. So we said like terms, same variable, same exponent. So -x is just like -3x. And then -2 will combine with 10. And so once we combine those, we should end up with -2 plus 10, that's 8. And -1x minus 3x is -4x. Let's look at some solving. So solving has to have one of these symbols. It has to have it, otherwise you cannot solve. So beat that into your brain. If you don't see one of these symbols, you cannot solve. There is nothing to solve. Your first step, look, it's the same thing. You're going to undo grouping. Guess what second step is? Oh, look, it's combine like terms. And here is where solving gets different from simplifying. Then you're going to move terms with addition or subtraction. That's step 3. And step 4 is you're going to make the coefficient in front of your variable 1 by multiplying or dividing. And there's something really important you got to notice. For steps 3 and 4, you got to do it both sides. And both sides, I mean both sides of whatever little symbol you have. Notice, since we don't have that symbol for simplify, you can't do steps 3 and 4 because you don't have two sides to it. Notice, we don't have two sides here. We can't do steps 3 and 4, so we can't solve. All right, we're going to do 2 examples. Here's the first one. -2 plus x is greater than -3x plus 10. So we said our first step, undo grouping. And so once again, I'm going to say it a bajillion times. That negative is really -1. So multiply -1 by 2, multiply -1 by x. And you should get this, -2 minus x greater than -3x plus 10. All right. Well, I don't see any like terms. When we say like terms, it's got to be on the same side. So if we built our little wall, we don't have like terms on the left, we don't have like terms on the right. So let's get all our variables to the left. So that means that we're going to take this 3x and we need to get over to the left. To do that, I'm going to add 3x to both sides. When I do that, I get -2 plus 2x, because -1x plus 3x is 2x, is greater than 10. Don't forget to bring down that 10. All right, we still have a problem because we have x and a number over here. Those are not like terms. We need to get this number over to this side. To do that, we need to add 2 to both sides. So when we add 2 on the left, that'll cancel out the -2. So we just have 2x. And then hopefully we all know that 10 plus 2 is 12. There we go. 2x is greater than 12. We're almost at the end. So notice whenever we added and subtracted, we did it to both sides. Now we need to make that coefficient 1. Right now, here's our coefficient. That's a fancy way of saying the number in front of your variable. It's 2. To make it 1, we've got to divide both sides by 2, because right now 2 is being multiplied by x, and so the inverse operation is division. So when we divide both sides by 2, we should get x is greater than 6. All right, one other example that you might see, and by might, I mean you're going to see it in a minute, is you might be given an equation like this. So this is the equation for density. It says mass divided by volume equals density. So m is mass, v is volume, d is density. I promise you're going to use this in chemistry class. And then I might tell you solve for m. There are no numbers, so you've got to figure this out. When it says solve for m, it means get everything away from m. We want m by itself and everything else on the other side. So to do that, right now m is being divided by v. The inverse of division is multiplying, because we don't have any grouping, we don't have any like terms, we don't have anything to add or subtract, so we're going to skip right on to multiplying or dividing. So V is dividing M. So the inverse of division is multiplying. So I want to multiply both sides by V to get M by itself. So that would look something like this. V times M divided by V. So notice this is my original, M over V, equals D times V. So I multiplied this side by V. I multiplied this side by V. Well, guess what? Those two V's right here cancel out. So you get M equals dV. And we solved for M. We did exactly what we were asked. Another mix-up I see a lot is the difference between is less than and less than. Very similar. So when I say is less than, I'm talking about this symbol, the less than symbol. So write down these examples. Here's our first example. 5 is less than a number. So take a moment, think what that would look like if I wrote it as an expression instead of words. 5 is less than a number. So remember, when we say a number, we're just going to put in a variable like x. So we want to say 5 is less than x. So it should look like this. 5 is less than x. Here's another one, a little more complicated. Twice a number is less than 6 added to the same number. So when we say a number, again, we're going to talk about x. And when I say the same number, I'm still talking about x. So twice a number is 2 times x, or more simply 2x. Then we want is less than, the symbol, 6 added to the same number. So 6 plus that number x. We get this, 2x, twice a number, is less than 6 added to that same number. Now that's confusing because we could say less than and be talking about subtraction. For example, and remember, write these down. 12 less than a number is 5. If you remember way back in our notes, it's been a few weeks, we said whenever we see this less than, we need to be careful because we want to just put 12 minus x, for 12 is less than a number. But that's not right. You want to flip-flop these. So instead of doing 12 minus x, you're going to do x minus 12. And then is 5 is the same as equals 5. Oops. So x minus 12 equals 5. That's the way of writing this. 12 less than a number. Flip-flop it. Here's our number, less 12. Let's do one more example. 6 is greater than 10 less than 8. So 6 greater than, that should be simple. 6 and the greater than symbol. 10 less than 8, be careful. That's going to be 8 minus 10. Again, we flip-flopped. Even though when we wrote it out, we said 10 first. When we write it as an expression, put your 8 first. Oh, inequalities. We're actually pretty good at inequalities, except we get confused as to when to flip that sign. You only flip it when you multiply or divide by a negative number. And if you multiply or divide by a negative number, you have to flip the sign. It's the #1 mistake people make. So here are the examples you're going to write down. 2x greater than 10. Simple example. All we got to do is make our coefficient 1. To do that, we divide both sides by 2. When we divide both sides by 2, you should get x. Oh, there we go. X is greater than 5. Notice we divided by positive 2, so don't flip the sign. Here's another example. Negative 2x is greater than 10. So here, we divide both sides by negative 2. Well, let's see how good my writing is. Oh, not so good. I'm doing my best, I promise. Negative 2. All right. When we do that, the negative 2's over on the left cancel. So we get x is less than negative 5 because we divided by a negative number. So this sign, greater than, flipped to less than. All right. In a little bit, we're going to go to part 2, but this is the end of this video. Please go to Schoology to see the examples that you need to do.